So, picture this. It's the 1920s, and a mathematician named David Hilbert dreams up this thought experiment. It's a hotel, but not just any hotel. It has an infinite number of rooms. And this wasn't just for fun. It was designed to completely challenge how we, as humans, think about the very idea of infinity. And that brings us to the core puzzle, the thing that makes this so mind-bending. How can a hotel that is 100% full, with a guest in every single room, always have space for more people? Not just one more person, but busloads, even infinite busloads. Sounds impossible, right? Well, let's check in and find out. All right, so let's meet the hero of our story, the hotel's night manager. He's got a full house tonight. Every one of his infinite rooms is occupied. Seems like a pretty quiet night ahead. Until, of course, the front door swings open. So, a new guest walks in and asks for a room. Now, in any other hotel in the world, the answer is simple: sorry, no vacancy. That's the end of it. But this isn't any other hotel, and our manager is about to do something that feels like it breaks the laws of logic. The solution is actually kind of simple, but it's pure genius. The manager gets on the hotel's intercom and makes an announcement. Could every guest please move from their current room, room N, to the next room over, room N+1? So the guest in room 1 moves to 2, 2 moves to 3, and so on forever. Since there's no last room, nobody gets left out in the hall. And just like that, boom, room 1 is now completely empty for the new guest. And here's the really cool part. This trick scales up. What if a bus carrying 40 people pulls up? No problem at all. The manager just asks everyone to move 40 rooms down the hall, from their room N to room N+40. And poof, the first 40 rooms are now vacant. The key thing to remember here is that for any finite group of new arrivals, this simple shift always works. So our manager's feeling pretty good. He's got a system. But just when he thinks he's seen it all, he looks out the front door and sees a problem pulling up that his little shifting trick just can't handle. Things are about to get a whole lot weirder. And there it is, a bus that is infinitely long, and it's carrying what mathematicians call a countably infinite number of passengers. Now, that phrase is super important. It basically means you could, in theory, count them all. 1, 2, 3, and so on. You just never stop counting. But how on earth do you make room for infinity more people when you're already infinitely full? Well, the old plan is a total bust. You can't just ask guests to move to room N plus infinity. Where even is that? Infinity isn't a number you can add, it's a concept. There's no end of the hallway to move to. So the manager needs a totally new strategy, one that uses the weirdness of infinity to his advantage. And the new plan is absolutely brilliant. He gets back on the intercom and asks every guest in room N to please move to room 2N. So the guest from room 1 moves to room 2. The guest from room 2 goes to room 4. Room 3 to room 6. You see what's happening? All the original guests are now safely in the even-numbered rooms, and that means all of the infinite odd-numbered rooms are now completely empty, ready for every single passenger from that infinite bus. Problem solved. Okay, so we've handled one guest. We've handled an infinite bus. Surely that has to be the limit, right? You might think it couldn't possibly get any crazier than that. But you would be wrong. So wrong. This is the moment the unthinkable happens. The manager looks outside and sees it, an infinite line of buses. And yes, each one of those buses is carrying an infinite number of passengers. I mean, can you even imagine? We're talking about infinity times infinity. This seems truly mathematically impossible to solve. Just when it seems like all is lost, our manager has this incredible moment of insight. He remembers something he learned from way back, a proof from the ancient Greek mathematician Euclid. And that proof is that there are infinitely many prime numbers. You know, numbers like 2, 3, 5, 7, that can only be divided by themselves and 1. This ancient idea is about to save the day. Okay, hang with me, because this solution is the most amazing one yet. First, he takes care of the current guests. He asks the person in room N to move to room number 2 raised to the power of N. Then he assigns each of the infinite buses its very own prime number. So everyone from the first bus gets a room based on the prime number 3. The passenger in seat N on that bus goes to room 3 to the power of N. The next bus uses the prime number 5. The one after that uses 7, and so on, forever. And here's the magic. Because the fundamental theorem of arithmetic tells us that every number has a unique prime factorization, a power of 2 can never equal a power of 3, or a power of 5. It guarantees that no two people will ever be assigned the same room. Everyone gets a spot. Now, as a funny little side effect, a lot of rooms are now empty. Room 6, for example. It isn't a power of a prime, so it just stays vacant. But hey, that's a small price to pay. So we've seen all these mind-bending solutions. But the really big question is, why? Why does any of this work? How is it even possible? Well, the answer has to do with the very specific kind of infinity we've been playing with. Turns out, not all infinities are the same size. It all comes down to this idea of a countable infinity. The mathematician George Cantor called it Aleph Zero, and it's basically the smallest level of infinity. A set of things is countably infinite if you can put them in a list, if you can match every single item to a counting number, like 1, 2, 3, 4, and so on. It's this listable quality that our manager has been cleverly exploiting this whole time. So wait a minute. If there's a lowest level of infinity, does that mean there are bigger ones? And the answer is a resounding yes. And it's the reason our manager's tricks work at all. He's dealing with the most basic kind. Here's the key difference. On one side, you have countable sets, like our hotel guests, who you can line up and count. On the other side, you have uncountable sets, like the real numbers. That's all the whole numbers, all the fractions, all the decimals, and all the irrational numbers like pi. You physically cannot put all of them into a single ordered list. And if the hotel rooms were numbered using that system, all of the manager's clever tricks would completely fall apart. And I mean, just imagine how chaotic that would be. A hotel with real number rooms would be wild. You'd have rooms in the basement with negative numbers. You'd have fractional rooms like room 1/2 tucked between 0 and 1. You'd have room pi, where I assume guests would demand free dessert. It's a fun way to picture a kind of infinity that's just too dense, too packed to ever organize. And really, that's the whole point. Hilbert's Hotel isn't a business plan. It's a mental gym. It's a beautiful paradox designed to stretch our brains and show us that the rules we use for our everyday, finite world just don't apply when you start dealing with a concept as massive and counterintuitive as infinity. Which leaves us with one last big question to chew on. After watching our manager shuffle infinities around, does that mean infinity is a real, tangible thing that we can work with, just like any other number? Or is it just a pure concept, an idea that only exists in our minds to describe something that simply has no end? It's a pretty deep thought to check out with.